Wirefeed welding was first developed in the 1940s as a way to increase welding production. Originally it was called MIG welding, which stands for metal inert gas, but when they started using non-inert gases, it was required to change the name to GMAW, which stands for gas metal arc welding. The safety protocol for GMAW is much the same as most other processes. We have our safety glasses, we have our welding helmet, typically a shade 10 lens depending on what amperage you're using, welding jacket, welding gloves, steel toe boots, and very good ventilation. This is a typical multi-process machine, whereas all of the wire feed components as well as the power components are all combined into this one unit. In the front of this machine, you can see that there's a computer panel. This controls your voltage and your wire feed speed, as well as what process you are using. Inside the machine, you can see at the rear, we have our wire feed spool, which is your actual wire. Then we have our drive roll setups, which push the wire. Then coming out of the machine, we have a whip that actually connects to our gun, and all that wire goes through that entire system. This is a closer look at the drive roll. The drive roll system is connected to basically an electric engine which drives and spins these drive rolls when we pull the trigger on our gun. So when we pull the trigger, that initiates these drive rolls to start spinning. On the right top corner, you can see that there's a little lever that's sitting down. That lever is your tensioner. So that is what actually clamps down on the top drive roll and creates pressure that pushes the top drive roll into the wire, which causes friction so that we can actually pull the wire through the system. If you look here, we have grooves within the drive roll setups, and these drive rolls are actually interchangeable depending on what type and size of wire we're using. So if you're using flux core, you use a different type of drive roll. If you're using solid wire, which is you see here, you use a U groove. This is your backing gas. Backing gas is very important for your weld to prevent porosity. This tank is a high pressure tank, much like your oxygen tank. And then we have our regulators, which have the pressure in the tank. And then we have the reduction, which is your working pressure on the left-hand side. This is the whip and the gun. The welder uses gun and manipulates it in certain actions to create the weld he wants to make, depending on what type of process he's using. When the welder pulls that trigger, he is initiating the drive rolls, which start spinning and pushing the wire. He initiates the power contact on that contact tip, and he initiates the backing gas. Starting from the left to the right, I'll describe these components. We have our nozzle, which directs the backing gas right over the weld. Then we have our contact tip, which is a very important component that actually contacts the wire and it creates the power needed. And then we have our diffuser, which the backing gas flows out of. This is an internal breakdown on your whip. The outer layer is a rubber protective layer. Then we have a cloth which allows flexibility. We have our control wires. Then we have our power cable, our diffuser gas hose, our conduit, and our wire. The conduits can be made of different materials depending on whether you're using steel or aluminum. Aluminum generally is going to be nylon or plastic liner. These steel ones are actually hardened steel because they need to be harder than the wire going through it. The most typical hand tool that a wire feed welder needs to use is a set of wire feed welding pliers. The tips of these actually are square edged, so you can actually remove slag and spatter within your nozzle. The next hole down is to grip your contact tip. Then we have snips, and below that we have a diffuser grip. We also have different brands of welders as well as different types. So this one is actually two separate units. On the top we have our wire feed unit, which is separate from the power unit that's down below it. The dial on the wire feed controls your wire feed speed. The dial on the power controls your voltage. This unit is actually dual control. So some processes within Wirefeed require a root run with a solid wire and then a fill with maybe a flux core. So this provides for easy transfer from one process to another. We can just set one up and set the other up and have it instantly accessible. Right here we have a spool gun. This actually would contain a 1 pound, usually aluminum spool within the back right hand side here. Then there's drive rolls that are actually connected within the actual welding gun. This is another type of gun, usually for aluminum when you're dealing with longer lengths and higher production. So we would have a normal drive roll setup like we've seen before on the other side of the unit. Then we've got a long length, and then we have an extra set of drive rolls that help continue pushing that wire through. We can take a look here at the difference between stick welding, SMAW, or shield metal arc welding, and then a flux core T9. These specifically is a 7018 on the top and a T9 wire on the bottom. Here are some more examples of wire feed welds. These are vertical welds done with S6 solid wire. The first weld on the left is an inside corner, the middle weld is a lap joint, and the furthest to the right is an outside corner. It is generally assumed that the skill level to actually manipulate these welds is lower than with stick welding. Where the complicated part lies and the real talent lies within the welder is being able to troubleshoot and maintain their gear, as well as pick and choose the proper settings for each different type of process. Okay, if you can do that, you can produce a lot of welds.